Hey guys, today we have an interview with Eric Elliott. Eric Elliott is a JavaScript developer. He's also written a lot about functional programming, has a pretty good Medium articles and blogs that he's written. In this interview, we talked to him about functional programming. We talked to him how you should prepare for an interview, a JavaScript interview, and much, much more. This interview is audio only. I actually did it last year with him. So just sit back, put your earbuds in, and listen to it. It's well worth it. Let's take a look. Hi, this is Eric with programwitheric.com, and I'm here with Eric Elliott. He is an author, a developer, blogger. He's written books from programming JavaScript applications to learn JavaScript universal app development. He's done everything JavaScript. And today I am going to start asking him some questions about interviews. And I think that'll be kind of an interesting topic for today. But I'd like to start off with just asking you a little bit about yourself. Can you tell us a little about yourself, Eric?
Sure. And I started programming when I was really young, about 6 years old, something like that. And I was really into it for a long time, and then I took a little break and started doing other kinds of creative things. And 2008, stock market collapsed, and I lost my income, I lost my life savings, lost my home, everything. And of course, that's when I met my wife and decided to ask her out when I was broke and couch surfing. Anyway, she encouraged me to look at programming jobs again. And I'd been a JavaScript developer for years and years. And I'd built some really serious apps in JavaScript, but up until that point, nobody really took JavaScript seriously, and most people thought it was just a toy to make things move around in the browser. So when I looked back into it and I saw that people were paying real salaries for JavaScript developers, all of a sudden I was really surprised and happy. And took a job with Zumba Fitness and quickly turned around our life and got out of that struggle that we were in. And from then on, I discovered very quickly that most people really don't know anything about JavaScript. They know a little bit, enough to kind of get around and do useful things and be dangerous, but they don't really know how to put together serious applications in JavaScript. So I wrote the book Programming JavaScript Applications, which O'Reilly picked up pretty quickly, just because it was a really desperate need in the JavaScript community. And when I say desperate need, I mean like I was interviewing developers, and 99 out of 100 of them couldn't answer basic questions about how JavaScript works, meaning like they didn't understand closures, they didn't understand callback functions, higher order functions, that sort of thing. And they didn't understand how JavaScript's object system worked. And if you're a JavaScript programmer, you know that we use closures all the time. We use callbacks all the time. Everything's all asynchronous. So it's really important to understand those mechanisms and how they work. And we also do a lot with objects, because JavaScript, despite popular heckling, JavaScript is an object-oriented language, and we use objects all the time in JavaScript. So understanding those two things, I call them the two pillars of JavaScript, I think is the most important thing that you can learn in JavaScript. So I devoted most of my life when I wasn't working on an app to teaching other developers how to code and how to use JavaScript well.
That's awesome. Where can we find those books, by the way, if someone wanted to go and get them?
So the O'Reilly book, go to pjabook.com, and it'll take you to the book website where you can buy my ebook and paperback bundle. It's PJA book for programming JavaScript applications.
Okay.
And that, if you go there, all the table of contents, it's all linked. So you can click on those links, and it'll take you to the free version of those chapters online. So you can read it before you buy it if you want to.
That's great.
So
Yeah, pgabook.com. I'll put that in the show notes, and then yeah, we'll be able
cool.
to look at it.
The other one is on LeanPub, and it's not ready yet. So I haven't released the pre-release version of that yet. Planning to do that in early next year, probably. So.
Oh, awesome. Some new stuff coming up down the pipe. I know that the programming JavaScript applications, I'm also taking some graduate classes at my university, and our university system had that in there. They have a deal with O'Reilly, and they have a bunch of books. I was reading that the other day,
Cool.
which was great. That was being offered. So you mentioned a little bit about developers and how they're, I mean, if you talk to 10 developers who say they're web programmers and you start asking them JavaScript questions, you find out quickly that a lot of people don't really understand JavaScript, or just barely understand maybe just the fundamentals.
Yeah.
So if you're, so let me ask you this: if you were trying to get a web development job, um, how, and you're trying to, let's say you're it's going to be dealing with a lot of JavaScript, how do you prepare for that typical interview? What would you suggest?
So if I was a beginner trying to get a JavaScript job, like my first JavaScript job, the first thing that I would do is I would go and Google closures and figure out how closures work.
Mm-hmm.
Um, and I would say learn what callbacks are, and learn how to do asynchronous programming in JavaScript. Learn promises, um, and because those are things that you're going to be using every single day in your job, and and then learn how to use object.assign, and learn how to use the array extras. They're the array methods like map and reduce, um, and, and those are really important. Map, reduce, and filter are the
Filter,
ones that
yeah.
you're going to use all the time, all the time. Once in a while, you might use for each, but try to favor map instead of for each if you can. Um, and those functions are like your utility belt functions that you're going to use on a regular basis. Look into the library Lodash, because almost every um, almost every big app I've built in the last few years has used Lodash, and primarily because it's a functional utility belt. It's got a lot of the the functional programming methods and functions that you're going to be using all the time on the job. So learn Lodash, and that'll be a really good start. Um, I would say you're going to need to know a little bit of ES6, because a lot of people are moving over to it right now. We're making the transition into using the latest version of JavaScript, and a lot of companies are moving to it before it's implemented well in all the browsers. And the reason for that is that it adds a whole bunch of really great features that make JavaScript a lot less verbose, a lot easier to read, and a lot more expressive. So it added a whole bunch of really great syntax that is going to help you write more compact JavaScript. So learn ES6, especially destructuring is going to be really important. Um, parameter defaults are really important. You're
Mm-hmm.
also going to be using REST parameters and spread a lot. Um, there used to be some really confusing stuff with JavaScript has an arguments object where you can get all of the arguments for a function. And it used to be, before the REST parameter came around, it used to be that you had to do some tricky hijacking of that arguments object, turn it into an array, and then use array methods to manipulate it. But with the REST parameter, you just do dot, 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 and then a name, and then it turns that into an array of the parameters, which is great. So learn that stuff, and you'll be on the right track if you know some of that syntax for ES6. Um, you're also going to want to know what prototypes are, and most JavaScript programmers, even experienced JavaScript programmers, have a deep misunderstanding of prototypes. So a prototype is just a regular JavaScript object, and you're going to have a target object that you're going to have. You're going to try to access properties on that target object, like a method or some properties on that object. And if the property is not found on that object, it looks up a delegate prototype. It's got like an internal link to a prototype, and it looks up the prototype chain. So each object has a prototype all the way up to object.prototype, which is the root level. And some objects can have no prototype if you specifically design them that way, but most of them have a prototype, and it'll look at the prototype chain and search for the property on those prototypes. That's called a delegate prototype because it delegates that property access to another object, a delegate object. There's a design pattern from the book Design Patterns, came out in 1994. Elements of Reusable Object-Oriented Software by the Gang of Four. It's a really famous book. There's a pattern in there called the flyweight pattern, and JavaScript's delegation system gives you the benefits of the flyweight pattern in JavaScript for free, and that's what delegate prototypes are essentially. So learn what a delegate prototype is, how to set them up, and how to use them. There's various ways to do it. The way that I recommend is using object.create. And the popular common way to do it is to use the class keyword. So you're going to have to learn the syntax of the class keyword, but I strongly recommend that you avoid using it as much as you can. There's a lot of reasons for that. You can search my blog for a ton of them. My blog's called JavaScript Scene, and it's on Medium. So I've got a bunch of articles on there about that, including the 2 pillars of JavaScript Part 1. I've got another one on functional programming called the 2 pillars of JavaScript Part 2. And those will go into a lot more detail, and there's a lot of links associated with that stuff, that learning that you can find on my blog. So that's a start. That's only one type of prototypal inheritance, though. And most JavaScript programmers don't know this, but there's actually more than one type of prototypal inheritance. The other important one to know is a concatenative inheritance. And that's basically what most JavaScript developers call mix-ins. And that's what I mentioned object.assign for, is because it's the easiest way to do mix-ins in JavaScript now. But that basically just means that you look at properties of a source object, the exemplar prototype. You look at properties of the source object and just copy those properties into your new object. And you can use that to compose objects together. So object composition is very, very easy to do in JavaScript, and it's a really effective method. And every JavaScript developer should know how to do that. And then there's another form of inheritance in JavaScript that Douglas Crockford coined it functional inheritance. And the way that he wrote it, you create something called a factory function. In JavaScript, any function can create a new object. So any function that returns a new object for you is a factory function. So you don't have to use constructor functions, which are commonly used in JavaScript. There's a lot of problems with constructor functions, especially with the new keyword. Kind of ties you to the constructor implementation, and it limits what you can do in the future with that type of object. So I would avoid those if you can and use factories instead. But what factories give you is the ability to create a closure, which can any variable inside of that closure, when you return the new object, the object's methods can access those variables. So it gives you kind of like private properties from other languages, but they're just created using closures instead of class properties. So it gives you the ability to add private data to your objects, which is going to be essential to understand how to use them and how to recognize them when other code is using it. So yeah, learn those. Those are all really essential JavaScript basics. And 99 out of 100 developers that I interview don't know, they can't answer basic questions about any of that stuff. So learn that stuff. Learn that stuff, and you'll really stand out in a job interview about JavaScript.
Yeah, I've been writing all these down. There's quite a bit that you mentioned here.
Yeah.
For sure, it's just I mean, I've been writing a little bit about ES6 and some destructuring and some of the other things with that, and that's what I've been focusing on. But just really knowing the basics of like you've told, but like you've been saying, what's the promises, make sure you understand asynchronous callbacks, map, reduce, filter, those type of things are extremely important. I agree.
Yeah.
And I already know the answer to this, but how important is it to know your algorithms, or what about puzzles? Meaning that, traditional CS degree, you learn about, create your linked lists, things like that. How do you think that applies during job interviews?
So there's a strange kind of paradox in the JavaScript job market, and that is that most interviewers use things like puzzles and algorithms and whiteboards to evaluate the effectiveness of a JavaScript developer. So chances are, if you're going out for a job coding in JavaScript, you're going to get questions like that. The other side of that paradox is that the evidence shows that performance on those things has absolutely zero correlation with job performance. So people who are doing those kinds of interviews, they're not getting very interesting, actionable data from those interviews. So if you are interviewing, avoid those questions and instead concentrate on the basics. All the stuff that I just talked about, concentrate on asking questions about that stuff, because that's going to tell you what you really need to know about JavaScript developers. Do they understand how objects work in JavaScript? Do they understand how closures work? Do they understand how asynchronous programming works in JavaScript? That's the stuff that they're going to use every day when they're building your application. So that's the stuff you need to ask about. Now, as a new developer going into a job, definitely learn all that stuff that I talked about first, because those are the fundamentals. That's the stuff you absolutely need to know to perform on the job, right? So you could go out and study a bunch of puzzles. You could. There's a book for that, and it does help you pass those kinds of interviews. But your time is going to be much better spent if you learn the stuff that you really need to know for the job, because it's not going to do you any good if you get the job and then a month later you get fired because they figure out that they hired somebody who has no clue what he's doing, right? So
Yeah, exactly. Do you believe that on top of knowing these things, that being able to do like a take-home test? I mean, when you interview candidates, do you make them do a take-home test, or?
I don't do take-home tests. Instead, I recommend people, anybody that's seeking a job in programming, um, put together a simple app and put it up on GitHub. And then when they ask you about stuff that you've done, or even just in your resume, post a link to that sample app and say, here's an app that I built. It's on GitHub. You can download it, you can run it, you can check it out, and you can look at the code, and the person hiring is going to be able to look at your code and see that you're not writing complete nonsense spaghetti code. And
Yeah.
they'll know right away that you're a competent programmer, or at least you know how to steal from a competent programmer. um, so to interviews, people who are interviewing JavaScript developers, I highly recommend that you ask for a code sample. If they don't have one already on GitHub, do ask them to complete a simple coding assignment. And that is definitely the best way to just like weed out the people who can't code their way out of a paper bag, right? Um, Ask somebody to like pull in a Twitter feed and display it on a page. using whatever like hashtag you want them to use, or sorting in whatever order you want them to sort in. So you could say like most recent at the top or most recent at the bottom. Just mix it up so that they actually have to code a little bit to make that happen. And that's the best way to weed people out. Instead of doing crazy, stupid things like Fizzbuzz. Yeah, every coder who's been around for a few years has seen Fizzbuzz. They know how to implement it. If they don't know how to implement it, they know how to Google for it and look it up and pretend they know how to implement it, right? So that doesn't work. That stuff, forget about all of that stuff. Pretend.
Do you think it's
Yeah.
that stat going out there that 60-70% of programmers can't even complete a Fizzbuzz? Do you think that's real?
Uh, I think that most people applying for programming jobs, most people applying for junior level programming jobs, probably um, probably couldn't complete the Fizzbuzz assignment. Um, and I would even include people who are computer science graduates in that list. And and the reason for that is that a lot of people, they don't really practice programming when they're just getting started. They read a lot about it, they go through a bunch of books, but they're not really practicing. So if you're just learning JavaScript, my best advice for you right now is to stop just reading about it. Actually implement code. Um, don't just copy the assignment verbatim out of the book or whatever and run the code and go, oh wow, that works. Mess around with it, change the code, do something different with it, apply it to a problem that you have, or just come up with a silly game that you can make with it. Play around with it, because the best way to learn how to code is to actually code. And speaking of which, the best way to evaluate a candidate is to do some pair programming with that candidate and watch them code. So if you want to know if somebody can code, watch them code. Right?
That's pretty funny. Yeah, something seems so obvious, but I think a lot of hiring managers probably miss that. Or
Yeah,
when they're
and
you know
a lot of people think that they can just ask them to write something on a whiteboard. Forget that. Take your laptop into the room and ask them to code on the laptop, because people don't code on a whiteboard for a living. That's not how it works, right?
right.
They need to watch the program run. They need to see where it's failing so that they can correct the silly typo or whatever, right? Um, like they need to know, oh, I accidentally lowercase this variable name, and if they have a coding environment right in front of them, they're going to get some kind of an error, and that error feedback is how we turn crap that we're just like slapping down on the paper, right, into something that actually works and does something useful, right? And
Right.
programming is all about getting that immediate feedback, doing something to change that and make it better. It's an iterative process. And programming on a whiteboard is the opposite of that iterative process. It's you're expecting somebody to get something perfect the first time while they're worrying about, is my handwriting neat enough? Are the letters slanting down at a funny angle? Am I going to get docked because this doesn't look pretty? Right? All that stuff is complete nonsense that has absolutely nothing to do with how a programmer is going to perform on the job. So that's my little rant. If you want to interview somebody well, put them in an editor and watch them code. Say, I need you to do this, and this is the problem. Go ahead and solve it, and watch them code.
That's some great advice for sure. Well, we have just a few more questions here. I know I want to be conscious of your time here. You talked a little bit about functional programming and object-oriented programming.
Sure.
So how do you think those two contrast to each other?
So traditionally, object-oriented programming is basically, the idea is that you collate the data and the logic that operates on that data. So data and behavior live in the same place. And that's kind of the opposite idea from functional programming. In functional programming, you write with mostly very small pure functions, which means given the same input, the function will always return the same output, and the function has no side effects. So side effects are interesting because one of the big problems with object-oriented programming is that you have all these objects scattered throughout your program, and any function can access any of those objects at any time and mutate the data for those objects. And the problem with that is that those functions can step on each other's toes, and it can cause real problems for you. So the idea of functional programming is to avoid side effects, eliminate them completely by using immutable data and pure functions. So it becomes a lot more like writing simple algebraic functions. Go back to your junior high school math class, right? And that's all you need to know about functions is those simple algebraic functions that you learned in junior high math class. So very, very simple stuff like adding two numbers together, right? If you add 5 plus 6, you don't change the value of 5, it stays the same, right? Instead, you return a new number that is a combination of 5 and 6. So then you've got 11 instead of 5 or instead of 6, right? And the value of the original parameters doesn't get changed, right? You're not mutating anything outside of the function. Instead, you're returning a new value, right? And that's the primary difference between functional programming and object-oriented programming. But functional programming has some really, really interesting features. So all pure functions are also idempotent, which means that you run them once, and the result of running it subsequent times does not change beyond what you got back the first time from running that function. So, and people from server-side programming understand this concept because so back in like the early 2000s, it was really common that you'd go through a shopping cart and you would land on this checkout page and you'd submit, and then you'd get a message that says, don't hit the back button, don't interrupt this process, right? Because it's going to checkout, right? And if you click submit twice, you're going to get charged twice because they were not using idempotent functions on the server side. So in other words, the server would get the same data, but it would repeat the process, right? And an idempotent function doesn't do that, right? It has no side effects. So for example, an idempotent function doesn't save any data to the database. It doesn't log anything to the console. It doesn't write anything to the screen. It just returns a value based on the input that you gave it. So it has really interesting repercussions in terms of how to write better server code. It also has interesting repercussions about parallel processing, because with a pure function, say you've got some complex computing to do, with pure functions, you can break up that computing into chunks and spread it across a number of processors, parallelize that work, and combine the results at the end. And you don't end up with things like race conditions that can plague object-oriented code or threaded code. So threading means that you've got a whole bunch of different threads that are basically like little mini programs running and processing things, and the threads run at the same time. But when a thread is operating on something, it creates what's known as a thread lock. So it locks everything else out of the resources that it's using so that it doesn't compete, doesn't get stepped on by other things trying to use that same stuff. Well, if there's no side effects, there's no need for locking. So, so using functional programming really simplifies problems like that by eliminating things like different functions competing for the same memory space. It eliminates the need to do that because there are no side effects to worry about. It also makes it really easy to parallelize your application. So you can you can get through a lot more, a lot faster, because you know that it's safe to run these things in parallel. And for example, unit testing becomes a lot better when you can run all your unit tests in parallel. So you can run your entire test suite in fractions of a second, when it normally would take several minutes, just because you can run all those tests at the same time if they're all made up of pure functions, right? Mm-hmm. So that's the primary difference. There are also some radical differences in terms of how easy it is to learn. So object-oriented programming tends to be very, very easy to learn because it tends to be really imperative, and it tends to model objects from real life. So you can kind of understand what an object is supposed to represent, and you can understand what is happening, what all the steps, the individual steps, are being taken to achieve the behavior that you're after. Because object-oriented programming also tends to be very imperative, which means you list each step in the process. You say, do this, then do this, then do this. Functional programming tends to be a lot more declarative, which means that we tell the computer what to do, but then how to do it is abstracted behind functions like filter and map and reduce and stuff like that. These are really general abstractions. But what ends up happening is that you eliminate all the looping logic, you eliminate all the a lot of the particular business logic that's dedicated to a specific type of object, right? You eliminate that and replace it with these really general abstractions of like filtering lists or dealing with data and using the same exact interfaces for every kind of data. And the interesting side effect of that is that it's really, really easy to learn object-oriented programming and its basics and follow what the code is doing. On the other hand, it's a lot more complicated to learn all of the potential effects of running a particular method using object-oriented code, because that method might affect the results of other methods and other objects, and you can't predict what a code change is going to do. So in object-oriented programming, you have really serious problems like the fragile base class problem. Fragile base class problem means that a lot of stuff is inheriting from a base class, right? And say you have a new use case that requires just slightly different behavior in that base class. If you try to change that base class behavior, everything else that you inherit from might break because it's dependent on the existing behavior, right? That's called the fragile base class problem, and it's a plague on the object-oriented programming community, and it's really a much bigger, much harder problem than a lot of people give it credit for. And I've seen it literally destroy companies. So it's a really big problem, and a lot of object-oriented programming people completely sidestep it, and they do that using object composition. But in JavaScript, you can use object composition without class inheritance, without the fragile base class problem ever even coming into the mix, by composing objects from multiple little objects, right? So if you compose from smaller pieces, you can replace any one of those pieces without impacting a ton of other dependent code. And you don't have that capability when you're using a base class and inheriting from that. So functional programming doesn't have a concept of base classes. It doesn't have any inheritance hierarchies whatsoever. So it completely sidesteps that problem. The problem just simply doesn't exist in functional programming. So it eliminates entire classes of problems like that you just don't even have to worry about. It also eliminates entire classes of code that you have to write. Like you don't write a lot of looping logic in functional programming because it's all abstracted away for you. So another interesting difference that's worth pointing out is that functional programming tends to be a much more academic topic. There's been decades of research and decades of math, typically dealing with like abstract algebras and calculus concepts that date back to the 1930s, the late 1930s, with with lambda calculus and stuff like that. So when you start Googling for functional programming terms like functor or monad, right, you're going to find a lot of really technical jargon that comes from things like category theory and abstract algebras and lambda calculus and concepts that a lot of people don't have a good background in. And if you're not a mathematician or if you haven't studied like that particular field of computer science in like a doctorate program, right, you're going to miss a lot of the explanations in functional programming, which really sucks. I think that's the worst thing about functional programming is that it can be really, really intimidating to new people trying to learn about it because they start Googling all these words and they just come up against this gigantic vocabulary of things that they don't know, right? And when you see like an ocean of stuff that you don't know, it tends to get really intimidating really fast. So that's the big disadvantage of functional programming. But if you can keep your head up, keep your spirits up, and realize, like, first of all, 99% of all the other people doing functional programming out there, they also don't have that vocabulary. They might know a few of the common words, like they know what a functor is, right? They know that a functor is just something that can be mapped over like an array or something, right? But they don't necessarily know what a homomorphism means, or a bunch of these other functional programming terms, and that's okay. That's okay. It's okay not to know everything all the time. There's a lot of that stuff I don't know yet because it's really a serious, deep academic vocabulary that you have to kind of learn very slowly over a long period of time. And I've been doing functional programming for years, and I still run across like category theory concepts that I've never heard of before. And when I go and try to explore it, it's some of it is just like too much jargon for me to digest, even though I've been looking at it for years. And that's okay. We don't have to know everything about everything, right? What you do have to know is the basics of what a pure function is. You have to know what side effects are, and you have to know when to try to avoid side effects. So an interesting thing about side effects is that any kind of I/O counts as a side effect. So if you write anything to the screen, that's a side effect. If you log anything to the console, that's a side effect. If you save anything to disk, that's a side effect. If you touch the network, that's a side effect. So it's important to understand that side effects are good, and we want those things to happen. We want a user interface to draw on the screen, right? We want to save stuff to disk. We want to hit the network. So I'm not saying don't use side effects. I'm saying that if you can avoid them, right? Favor pure functions when you can, when it makes sense, which is most of the time, really. So most of your stuff isn't I/O operations. Most of your stuff is like doing stuff in the business logic, right? So separating side effects from business logic is a really big thing. So yeah, that's kind of a probably much deeper overview of these concepts than you were asking for, but yeah, that's kind of the basic differences.
No, that's great. That's amazing. I'm not a functional programming whiz by any stretch of the imagination. I've used a lot of object-oriented programming in the stuff I do, but something I need to learn more about, and I feel the same things you were mentioning about. There's just the rabbit hole goes pretty deep with some of those terms and logics.
Yeah, really deep.
And so it can scare some people away.
Yeah.
Changing gears for a second, so in the larger sense, if you were looking at being doing web development and being a JavaScript programmer, how helpful do you think it is looking at the higher level JavaScript frameworks? Um, of course, from what you've told me earlier, definitely having a really good knowledge of the fundamentals of JavaScript, like we talked about earlier, is extremely important. What do you think about knowing frameworks as an addition, or is that not really that important to you?
So when you go out and you get a programming job, you're going to be using some libraries and frameworks. There's just no getting around it. And right now, the most popular one is Angular, but React is really, really hot. The popularity of Angular seems to be on the decline, meaning that like we recently ran a survey on my blog, and we discovered that um, there are fewer people interested in Angular than there are using Angular, which means they're looking at alternatives, right?
Hmm.
So I think that we're going to see a decline in Angular use in 2016, which is going to be quite a turnaround because it's been the most popular and the quickest growing framework for the last few years, since like 2013, 2014, and it's gonna turn around, I think. And I think that the big replacement is going to be React, which is interesting because React is not a framework in the same sense that Angular or Ember are frameworks. React is more like jQuery, which means that all it really cares about is dealing with the user interface stuff, right? So jQuery was great because it gave us easy access to the DOM. And knowing a little bit about the jQuery API is still important because that jQuery API it's mirrored in the DOM now. We actually took ideas from jQuery and put it in the DOM specification. So like query selector all is based on the jQuery selector, right? So it's important to understand the basics of jQuery. And I think that React is very much going to replace jQuery in a lot of situations. And that's really interesting because I know I just said that React was the most popular framework. Well, jQuery is still the most popular library by a huge, huge margin.
Yeah.
So like as popular as Angular is, it's just like barely a blip on the radar when you're looking at the popularity of jQuery. Um, so it's interesting that React is starting to displace jQuery. Um, so Angular didn't displace jQuery; it used it, right? And same thing with many other frameworks, including like Backbone, which was the big popular thing before Angular. It used jQuery. It used jQuery and underscore. Underscore was the predecessor to Lodash, basically. And then this robot from the future named John David Dalton came back and he created Lodash, and that kind of displaced underscore. But yeah, basic stuff. So I would say definitely learn React, definitely learn jQuery, even though it's being displaced, because you're going to see a lot of ideas from jQuery and a lot of other things, including the DOM itself. Um, and learn like the query selector stuff from the DOM so that you know basic manipulation of DOM stuff. Um, and all that's going to be really good. But the really cool thing about React is that it abstracts the DOM. So you can use React to do things that have nothing to do with the DOM. Like you can use React to draw pictures on the canvas. You can use React to create like animated UML diagrams. And this has nothing to do with DOM access, right? And you can use React to, Netflix uses it with something called Gibbon that, that Gibbon basically runs on these set-top devices. So that your TV consoles and stuff like that, all these little tiny TV streaming things, or your gaming devices and stuff like that. And the interesting thing about Gibbon is that they needed it to replace the DOM because the DOM is too heavy on a lot of these really low-powered smart TV devices and set-top things. So so they use React to draw their user interfaces on with Gibbon, which has nothing to do with the DOM. Well, little to do with the DOM anyway. So that's really cool. And we also have React Native now, which means that you can build mobile native apps using React, which is fantastic. So you've got the same basic architecture um, on your native device applications as you do on your web applications now, which is great. There were other, there was kind of faking it using web technologies to simulate your native device interfaces, but React Native is different because it actually does use your native device interface stuff.
React Native, huh?
Yeah, yeah. So it's a really great React is this really great abstraction that you can use to draw to just about anything, right? It's just this really great user interface abstraction, and I think that you're going to see a huge climb in the popularity of React. That it has already been like a rocket ship taking off, but you're going to see it's going to continue that momentum throughout 2016, I would predict, and maybe into the distant future, because it's just so useful to abstract away from the DOM.
Yeah, I've started playing around with React a little bit. I've been working mostly on Ember.js, but some of the things I've heard and what you've just described is pretty awesome with React. I definitely want to jump into it a little bit more.
Yeah. So Ember also has like a virtual DOM thing they call Glimmer. I haven't looked into that, but I think it's interesting that that React is starting to show up inside of inside of other frameworks. Like a lot of people who are making the transition from Angular apps are actually combining Angular and React, and I see that trend growing as people make the transition from Angular, and I think that that's a really interesting thing. And Glimmer is based on the work that they did in React. So
Right.
Glimmer does the virtual DOM thing to try to get the performance faster than the previous rendering engine. And I think that that's really great that we're seeing that kind of stuff pop up in other frameworks.
Yeah, I think the Ember people are definitely stealing some of the ideas from React
Yeah, definitely.
and trying to pull that in. I know I just listened to a talk by Yehuda, and he was talking about Glimmer too, that they're looking at 2016 to pull into Ember, maybe another update to what they're doing,
Yeah, yeah.
so which is really neat.
So
Well,
yeah,
go ahead.
there's one more thing that I want to address. I think the really great thing that frameworks give you over just like simple library, like utility libraries, is that they make a lot of decisions for you. But I think that that can help people understand how to structure an application. The problem is, I think they're making the wrong decisions for you in a lot of cases, and you kind of have to drink the Kool-Aid to use those systems. There's another kind of a trend popping up that I'm seeing in the React community is there's a lot of boilerplate projects popping up. And the great thing about boilerplate projects is that they do the same thing, except a lot of the times they're built out of a bunch of really small modular components. So the boilerplate projects are just pulling in little libraries that you could easily swap out if you want to. You don't have to drink the whole Kool-Aid of the project to get something useful out of it. And I think that that trend is going to grow. For instance, WordPress just announced that they've got a new user interface to manage your WordPress sites, and it's all built in JavaScript, and it uses Node and it uses Atom, so that you've got or not Atom, sorry, Electron, which is the desktop user interface stuff that is used by the editor Atom, right? Which is GitHub's editor. So the interesting thing about that stuff is that I think we're starting to see a transition from really opinionated frameworks into just starter projects that have a lot of the stuff that you're going to need, batteries included, in the box. And then if you want to change the way you do something, you can easily swap out the little libraries, the low-level utilities that it's pulling in. And I think that this is a really interesting trend. And I was just looking at what's that framework called? I don't know. Anyway, but I think we're going to see more stuff like that. I think we're going to see like WordPress type CMS things happening, and we're going to see projects built on top of those things. And I think that the trend might be that we're going to see less frameworky type stuff and more of that. But I could be wrong. We'll see.
Yeah, I saw that that medium, or I think it was Matt Mullenweg's, about the WordPress going to different that JavaScript. It was interesting in there. Yeah, and I definitely think these smaller composable units, these be able to swap in like you can do with React. Maybe you can just take some parts and put it into your app. That sounds, maybe that is the future. Maybe these larger opinionated frameworks, not as much.
Yeah. So the counterpoint to that point, though, is that they say that frameworks are batteries included, but when you actually get down to it, like if you look at the sample applications for Express, Node's Express framework, right? It's a handful of lines that gets a web server up. But yeah, great. Now, how do you connect to your database, and how do you do sessions and all that stuff? You kind of have to build all that stuff up from all those pieces, which means you have to go out and find the right pieces inside of JavaScript's gigantic NPM repository, 200,000 plus modules, right? And that's just a really big chore. And the thing that framework fans like to say is that you don't have to do all that stuff because the decisions are made for you if you opt into a framework. But the thing about the boilerplate projects is that some of them are pulling in these common things that just about every app needs, like configuration and logging and feature toggles and stuff that a lot of apps are going to use. They're included in these boilerplate projects. So there's examples out there that you can look at and you can see, oh, this is how they're building it. And you can either copy it wholesale and just swap out the parts that you don't need, or you have a really good example that you can just you can use as a reference. And I think that is going to be maybe the undoing of the monolithic frameworks. We'll see. Or maybe the monolithic frameworks will start to focus on different things, being prescriptive about the little micro libraries that you use instead of being like the gigantic library that you use.
Yeah, we'll have to see how that goes in the future.
Yep.
I think we'll definitely the monolithic frameworks will always be there, but we'll see how they evolve as time goes by.
Yeah.
Well, thank you, Eric, for all your great information. Where can people reach you at if they want to contact you or just say hi?
So I think the best thing to do, I think, is to check out JavaScript scene and follow that, subscribe to that. There's also, if you want to learn JavaScript from me, I have courses online at ericelliottjs.com. And so those members get access to my regular live webcasts, and they can ask questions, and I'll answer those questions for them during the webcast. So specific questions about things like how to do unit testing in React, or how to use this ES6 feature, or things of that nature. And I'm going to talk a lot about universal JavaScript and how to write applications with one code base that work on native devices, that work on the server, that work on the client, instead of like a lot of different applications. So good stuff to learn about.
That's great. And that's EricElliott.js.com.
Two T's.
Two T's.
Yep.
Okay, great. I'll put that in the show notes too. Thank you so much, Eric.
Thank you. Oh, there's one more thing that I wanted to mention really quick.
Oh,
so
please.
I mentioned that I've devoted myself to teaching people how to code. I think that this is a really, really important topic that we need to be teaching everybody, not just people who want to work in code, but it's useful in every kind of career. If you know how to code a little bit, you can advance your career. And I think that we should be teaching that stuff to kids in K through 12 curriculum. And I think that every kid should learn how to code. So my JS cheerleader asked me to host a movie. It's called Programming Literacy. It's a documentary film. And we're going into those topics about the importance of learning to code and the impact of code on our economy, and the fact that the kids that we're raising now are not learning how to code. And by the time they enter into the job market, 45% of the jobs that we take advantage with take for granted today, they're not going to exist anymore. So these kids are going to grow up, they're going to enter the job market and discover that they're illiterate in the job market, right? And I think that that's a big problem, and we're tackling that with the programming literacy documentary. So check that out, programmingliteracy.com.
Wow, that's awesome that you guys are doing that, and these are to help kids then, huh?
Yeah. So the idea is we just want to make people more aware of the importance of code, and why we believe that that it's really important that everybody learns a little bit of code. Everybody should be somewhat literate at code. So that's the idea.
I absolutely agree with that. Definitely.
Cool.
All right. Well, thank you again.
Thank you. It's been my pleasure.
Thanks. Thank you so much for listening to this interview. If you like these, please click that subscribe button. And I do have a couple of JavaScript courses I'm listing at the bottom here. They are affiliates, so I do get a couple bucks if you sign up for them. They're on Udemy. So take a look at those. Thanks, and take care.